Hey, in this video, I'm going to show you how I calibrate the Z-axis on my 3D printer, one of the most important steps before you start any print. If the Z offset isn't right, your first layer won't stick properly, and without a solid first layer, the whole print can fail. First, I need a lighter and a sheet of paper. Just kidding, the lighter's not part of the plan. But the paper? Yeah, that one we'll actually use. This is my go-to method for getting the nozzle just the right distance from the bed. If it's too high, nothing sticks. Too low and you're scraping the bed. Neither is fun. I'll walk you through how I do it, step by step, with some tips I've picked up along the way. Let's get started. So, the first thing I did with my Creality Ender 2 Neo was to enable the automatic leveling function using the built-in CR touch sensor, and honestly, it's a game changer. This little sensor physically probes 16 points spread all across the print bed. That's way more detailed than just checking corners or a few spots manually. What it does is measure the exact height differences at each point. So if your bed isn't perfectly flat, and let's be real, most beds aren't, the printer knows exactly where it's high and where it's low. Then, during printing, the firmware adjusts the nozzle's height on the fly, basically compensating for every tiny bump or dip it detected. This means your nozzle stays at the perfect distance from the bed across the entire surface, which is critical for that flawless first layer adhesion. Now, this technology is super cool and makes life a lot easier. But don't get me wrong, it's not a magic button that completely replaces manual leveling. You still need to get the bed roughly leveled manually, especially at those four corners. If the bed is way off, the sensor's compensation can only do so much. Think of the CR touch like a super precise fine-tuner, but the big adjustments? That's still on you. What's also neat is that this kind of 16-point probing gives you a detailed map of your bed's surface, which you can even review on the printer or in your slicer software. It's like having a diagnostic tool built right into your printer. Since enabling this feature, I've seen a huge improvement in print quality, especially on larger prints where uneven beds would cause issues. Warping and nozzle scraping are way less frequent, and the first layer comes out beautifully consistent every time. So yeah, automatic leveling with CR Touch isn't just convenience, it's a real technical upgrade that makes your prints more reliable, but pairing it with good manual leveling is still the secret to success. After auto alignment is complete, I always do a quick check with a piece of paper to see how close the nozzle is to the bed. If the paper doesn't slip under the nozzle at all, then the nozzle is too tight, which means the Z-axis offset needs to be adjusted. The auto alignment allows you to set the bed pretty close, but you can't always get the nozzle height perfect on the first try. So when I notice that the paper isn't coming through, that's the signal to manually calibrate the Z-axis offset. This is where I adjust the exact distance between the nozzle and the bed so that the first layer lays down correctly, not too tight and not too far away. I go into the menu, find the Z offset adjustment option, and then slowly raise or lower the nozzle while placing paper underneath until I achieve the perfect light drag. This step is very important because even the best automatic leveler can't replace this fine-tuning. Proper adjustment means better adhesion, smoother first coats, and fewer failed prints. I make sure that the paper goes under the nozzle, but it should not be easy. The nozzle should not be high above the paper. Once the nozzle moves to the home position, I begin manually moving the X and Y axes across the build plate. I make sure to check each corner carefully, because these are usually the spots where leveling issues are most noticeable. Note, here I am not calibrating, just repositioning the axes, and for quality adjustments, I set the Z-axis to 0. I go to the Y-axis and point it in any direction, at any of the angles we need to calibrate. I start manually adjusting the y-axis. What's cool is that when I turn the control knob to move the y-axis, the nozzle automatically moves along the bed to the exact spot corresponding to that control. Meanwhile, I keep my sheet of paper laid flat on the build plate, right under the nozzle's path. As the nozzle moves, I slide the paper back and forth, checking how it passes under the nozzle at different points. This way, I'm able to check the gap at 4 specific points, usually near the corners under the build plate. Since the adjustment is mechanical, I physically turn the knobs or use the printer controls to position the nozzle precisely over each point. At each point, I feel for that perfect light resistance when sliding the paper. If it's too tight or too loose, I adjust accordingly by turning the leveling screws under the build plate. This manual fine-tuning ensures that the bed is as flat and even as possible, even after the automatic leveling. Doing this 4-point manual calibration really helps catch any uneven spots that the sensor might miss and makes sure the first layer will stick consistently across the entire surface. After I finish checking and adjusting the points along the y-axis, I shift focus to the x-axis for the same detailed process. Manually moving the x-axis is super important because even if the y-axis looks good, there can still be slight variations front to back that affect print quality. When I turn the control knob, the nozzle glides smoothly along the x-axis, letting me position it anywhere I want on the build plate. I keep my trusty sheet of paper right on the bed, and at several key spots along the x-axis, I slide the paper under the nozzle. The goal is to feel that perfect balance. The paper should move with a gentle drag, not slipping too freely or getting stuck. This mechanical movement paired with the paper test helps me identify any tilt or unevenness in the bed that the automatic leveling might not fully correct. At this point, I'm especially focused on the front and back edges of the bed, since these areas can sometimes be slightly off due to slight warping or mounting irregularities. If I notice any spots where the nozzle is too close or too far, I fine-tune the Z offset or adjust the leveling screws accordingly. It's worth mentioning that on the Creality Ender 2 Neo, the bed is supported by springs and screws beneath the build plate. So turning those screws changes the height locally, raising or lowering the bed at specific points. This means I can customize the leveling to be as precise as possible in each corner and along each axis. By carefully repeating this process for both axes and all corners, I ensure that the entire surface is as flat and parallel to the nozzle's path as possible. This attention to detail at the calibration stage is what makes the difference between a failed print and a perfect, smooth first layer that sticks right where it should. And that's basically it. The full process of manually calibrating the Z-axis after automatic leveling. Taking the time to carefully check and adjust every corner, moving the nozzle across both the X and Y axes, and fine-tuning the Z offset really makes a difference. It ensures your first layer sticks perfectly, which is crucial for successful 3D printing. Remember, automatic leveling is super helpful and saves time, but it can't replace manual calibration completely. Trust your hands and eyes that simple paper test is still the best way to get the perfect nozzle height. Do this right, and you'll avoid common issues like poor adhesion, nozzle clogging, or uneven prints. Once you get used to this routine, it'll become second nature, and your prints will look way better. Thanks for watching. If this helped, don't forget to like and subscribe for more 3D printing tips. See you next time.